Today we are going to start about radioactivity and particles at Edexcel International GCSE Physics lecture notes, which were giving. Previous 6 sections are already done. And for the previous videos, kindly go for the playlist, okay? Um, and it is a request when you are watching the video, kindly subscribe the video, like the video and share with your friends so that it is going to be given in the form of knowledge to many of the students and the preparation can be done in a best way. Okay, today our topic is related to radioactivity and particles over there. Radioactivity is a process in which we can say that mostly the elements whose atomic number is greater than 82 show normally instability. They are not stable isotopes or elements over there. They continuously go for breaking down and converting into stable elements with the lower atomic number over there. Okay, let's move towards this topic properly. First of all, I will have to move towards the structure of the atom over there. And then what is atom basically? First of all, we will have to start with matter, which we say everything which has mass, everything which has mass and occupies space is called matter. And matter is made up of atoms, the smallest particles of matter, smallest particles of matter are called atoms. And these atoms are comprising, every atom is made up of three main particles, which are called electron, which are called proton, and neutrons. Where electron is having negative charge, proton is having positive charge, neutron is having zero charge. Electrons are present in the shells. Proton is present in the nucleus of an atom. Neutron is present in the nucleus of an atom. Let's suppose I say this is the nucleus of an atom in which proton and neutrons are present over there. And around them, there are shells of electrons in which electrons are orbiting the nucleus over there. As in chemistry, there are first shell, which is having 2 electrons. There are 8 electrons in the second shell over there for a stable monoatomic atom like neon over there. So the electrons are revolving around the nucleus over there. So nucleus of an atom contains protons and neutrons in the center over there. Here it is. Proton and neutrons are present in the nucleus over there. And it makes up most of the mass of the atom, but takes virtually no space. It is very tiny nucleus. So it is very tiny in the size over there. And number of protons in the nucleus is called atomic number. Number of protons in the nucleus is called atomic number there, and which is represented by letter Z over there. On the other end, proton plus neutron is going towards making the nucleon number. So we can say total number of protons plus neutrons present in the tiny nucleus over there is called mass number or nucleon number. For that, I will say here, in a tiny nucleus, the sum of proton and electron present over there is called atomic mass. Atomic mass or nucleon number. And represented by letter A. And if I go towards the periodic table for showing the elements over there, I will say, let's suppose there is an element X, which is having atomic number written in the below left side, and a mass number is written at the top of this number, and Z is number of protons only for any atom or ion over there, and atomic masses, number of protons plus number of neutrons over there. And we say the electrons, which are electrically negatively charged over there, as I have mentioned here, are going to revolve around the shells, and really, we can say these are very small in size and small in mass over there. They whiz around the outside of the atom, and the path takes up a lot of space, giving the atom an overall size over there. And if I compare all of these particles, then I will say electron is 1 over 1836 times smaller than the mass of electron is smaller than mass of proton. On the other end, mass of electron is 1 over 1838 times smaller than mass of neutron over there. And this is the basic information related to electron, proton, and neutron over there. Now I will have to move towards the key term that is called isotopes. Isotopes are basically the atoms of an element, atoms of a same element, of an element which have same atomic number, but different atomic mass. Atomic mass. So, for example, I take here hydrogen. Hydrogen is 1, 1, is related to protein. Hydrogen as 2, 1, 2 is deuterium for hydrogen. And hydrogen as 1, 3 is going to give me tritium. If I tell more about the details of these three isotopes, then I will simply say here, hydrogen with the protium is having 1 proton, 1 electron, but 0 neutron for protium. For deuterium, it is having 1 proton, 1 electron, and 1 neutron also. This is called deuterium. If we go for tritium, then I say it is having 1 proton, 1 electron, and 2 neutrons over there. This is the tritium structure over there. Protium, deuterium, and tritium case. And if I talk more about like carbon, is also having the isotopes carbon 12, carbon 13, carbon 6, 12, carbon 6, 13, carbon 6, 14. In the same way, 6 protons, 6 electrons for carbon 12, 6 protons, 7 neutrons for carbon this, 6 protons and 8 neutrons for carbon 14 over there. So even though carbon 14 is an unstable isotope of carbon, which is showing the radiations and will be used for aging purposes, like the determination of carbon dating, like how many years ago somebody is being dead over there, like dinosaurs, and this will be done according to the percentage of carbon 14 present in that bone over there. After that, there is, if we talk about radioactivity, then I say that in radioactivity, the process is totally is a random process. For example, I say to you here, there are, let's suppose there is a sample of 100 molecules over there. 100 molecules are present of radioactive substance, which is having its atomic number greater than 82, is naturally unstable. and it wants to decompose itself, then it means it will have to move towards the decay. After its one half life, what will happen? It will be converted into 50% over there. It will be converted into 50%. But I can't predict that which atom is going to decay to make it 50%. I will not say that it is like this is gone. No, I can't say that this center is gone. No. So I will say here that when I take the radioactive substance, the nuclei of unstable isotope breaks at random, means a radioactivity process, a radioactivity process of unstable isotopes, as I have given the example of carbon-14 over there, unstable process of unstable nucleus or isotopes is a random process. You can't predict that which particle is going to decay for that purpose over there. And each nucleus just decay quite spontaneously in its good time over there. So I will say here, the number one was the process is random, I can't predict. And the second one is the process will be spontaneous. And when we say some atom is going to decay over there, then we'll say it is completely unaffected by the physical conditions like temperature, because in chemistry, as you said, that as we increase the temperature or decrease the pressure is affecting something. In case of radioactivity, remember that these are not going to affect any kind of rate of reaction related to radioactivity over there. And when the nucleus does decay, it split one or more types of radiations, which we can name as alpha radiations, beta radiations, and gamma radiations over there, which are basically very informative, that alpha is having positive charge, beta is having negative charge, gamma is having no charge. But these are the radiations which we can say are to be taken into account in the next page, okay? In the process of nucleus often changes into a new element by the release of this alpha particle, by the release of this beta particle, or by the release of gamma particles. In case of gamma, element will not change, but the remaining all, it will be going on. In the last of this, we can say radioactivity, I will say here that there are background radiations in everywhere all the time. And those background radiations are always available after alpha, beta, gamma. Now I'm talking about background radiations. Like these radiations are emitting from radioactive isotopes over there. And these background radiations are there are high level, there is low level background nuclear radiations all around us all the time. It comes from substances here on Earth. Some radioactivity comes from air, food, building material like that. Radiations on Earth, they are available over there. After that, I can say here, after on Earth, I will say here that radiations from space, like cosmic radiations from the sun, cosmic radiations coming from the sun over there. After that, in the last, I will say here, living things, there is a little bit radioactive material in all living things over there. They are also emitting the radiations from their body because they have carbon-14 over there in their body structure. Radiations due to human activity like fallout of the nuclear explosion or bombing will be responsible for background radiations available in that area. After that, let's move to the next topic a little bit. That is also a subtopic of ionizing radiations over there. If I talk about the radiations which were being emitted, that were alpha radiations, that were beta radiations, And in the last, I will say there are gamma radiations. If we talk about these radiations, then how they are going to behave and how they are going to participate in their behavior, like I will have to go mainly with the two characteristics. One is ionizing radiation and second one is penetration of these radiations into an object to show some side effects or good effects over there. So nuclear radiations causes ionization because alpha particles are having, these are helium nuclei, helium nuclei with +2 charge over there. Beta radiations are just like electrons that can be beta positive or beta negative, having negative charge really over there. And gamma radiations are basically electromagnetic waves, electromagnetic waves which don't have any type of charge on their body over there. Nuclear radiations causes ionization of bashing into atoms and knocking out electrons out of them. So this ionization is done because of this +2 charge can be done easily, with minus charge can be done easily, but gamma radiations are showing no ionization when they are interacting with the particles over there. And there is a pattern, the further the radiation can penetrate before hitting an atom and getting stopped, the less damage it will do along the way, and so less ionizing it is. For example, if I talk about electromagnetic waves, they are not showing this phenomenon. It means they will have maximum penetration over there. They are having less penetration as compared to gamma particles. They are having very less penetration because they are having +2 charge to take off the electrons from the neutral atoms and causing the ionization at very high level over there. So ionizing radiations can be detected using Geiger-Müller tube, means all these three can be observed or can be detected by GM, Geiger-Müller tube over there. And this Geiger-Müller tube is a photographic film, and you need to know the details of these three different types of ionizing radiations over there. As I have told you about alpha radiation, that it is helium nuclei, then I will say here helium with 4 protons and neutrons over there, having +2 charge means no electron into it. Alpha particles are made up of 2 protons and 2 neutrons. They are big, heavy, and slow moving particles over there. These are slow moving particles present over there, and they are therefore don't penetrate far into the materials but are stopped quickly over there, means very low penetration over there. After that, I can say here that they can be stopped very quickly. Because of their size, they are strongly ionizing, which means they bash off into a lot of atoms and knock electrons off them before they slow down, which creates lots of ions, and ionization is going to happen with them. And because they are electrically charged with a positive charge, alpha particles are deflected by the electric and magnetic field. Means I can say here they are deflected by electric and magnetic field. Electric and magnetic field over there. If we talk like emitting an alpha particle decrease the atomic number by 4 and atomic number by 2 and atomic mass by 4 if some particle is going to be taken. Let's suppose I say here it is an element with the X symbol, atomic number is Z, atomic mass is 4, then I am saying that alpha particle is produced over there alpha with 2, 4, then what will happen? That X will be converted into its atomic number Z minus 2 and atomic mass minus 4 over there. So this is the behavior how they are going to decrease the mass by 4 and atomic number by 2 over there. On the other end, if I talk about beta particles, which are negative and show less penetration as compared to gamma particles, but more than alpha particles, these are electrons, which I have already told you that these are electrons that have been emitted from the nucleus of an atom when neutron turns into proton and electron. Here I am showing to you that if there is one neutron with 1 and 0 and 1 as its mass above over there, it is going to decay into proton with 1, 1 plus with beta particle in the form of electron with minus 1 and 0 over there. It means when it is come, this is the beta particle is just like electron, which is coming out in the result of radioactivity from its nucleus to make electron and proton over there. When beta particle is emitted, the number of protons in the nucleus is increased by 1. Here I am saying, for example, let's suppose you are taking the element Z with A, and what is happening? You are taking beta negative out, and in this case, I will say here beta with the 0 and minus 1 over there as its atomic number. I will say here that what I will have to do, that is beta negative. I'm taking Y as Z plus 1 and atomic mass staying the same over there. So this is the way how we will have to go there, because one proton is added and it is being taken in its atomic mass, no change over there. Let's move towards more detail of this. They move quite fast and they are quite small over there, and they penetrate moderately before colliding and moderately ionizing too between the alpha and beta, gamma and alpha radiations over there. They behave moderate behavior towards penetration and we can say ionizing over there, because they are charged so negatively. So beta particles will be deflected by electric and magnetic field is also showing their characteristics of electric and magnetic behaviors. Magnetic fields are going to affect their deflections, showing over there that they are negatively charged. And in the last, if I talk more about gamma radiations, that these are very short wavelength electromagnetic waves, means I can say here short wavelength electromagnetic waves. And in a way, we can say gamma rays are opposite of alpha particles. They have no mass, like alpha particles is having 4 mass. They are just energy in the form of electromagnetic waves over there. And I can say here that they can penetrate long way into material without being stopped over there. Means very high penetration, very high penetration they have. And in case of, we can say, this means that they are weakly ionizing because they tend to pass through rather than collide with atoms, but eventually hit something and do damage over there. I can say here that no ionization, because their speed is very high, then I will say it is no ionizing at all. And gamma rays have no charge. They are not deflected by, we can say, electric or magnetic field over there. They move straight line without deflection over there. And gamma rays emission always happens after beta and alpha decay. You never get just gamma rays emitted. Gamma rays emission has no effect on atomic or mass number. Like as I said, this is an element with X, atomic number Z, and atomic mass A. Let's suppose I say it is having high energy over there. What will happen? It will be staying as X, with Z, with A, and gamma particles is released over there in the form of energy. That high excited energy to the ground state or stable energy over there is being taken. If a nucleus has excess energy, it loses energy in the form of emitting gamma radiations over there. So if we go for detail, then all this process which I have done here for you, I will say, if I talk about alpha, beta, and gamma more, then I will say alpha can be stopped by blocked by paper, skin, or a few centimeter in air. It can be blocked by paper. It can be blocked by my skin. It can be blocked by few centimeter in air, few centimeter in air while they are going to interact with it and causing the ionization over there. If I go about penetration to identify about penetrating power of beta particles a little bit, then I will say here beta particles are blocked by thin metal of aluminum over there, blocked by thin aluminum metal. And if I talk about gamma, are blocked by thick lead over there. Gamma are blocked by thick, not thin, thick lead PB, that is lead PD, no PB, that is lead for it. And this lead is going to be taken that and very thick concrete of around about 30 centimeter concrete or concrete can going to stop the ionizing radiation of gamma radiations over there. So this was a little bit detail about these radiations. Remember that these radiations can be detected by Geiger-Müller tube to calculate the count rate of those radiations. And about I have already talked about when alpha particle is releasing, there is decrease in atomic number, decrease in atomic number by 2 over there and atomic mass by 4. And in case of beta particle, is beta negative decay over there. I said atomic number is going to increase by 1 and atomic mass is unchanged over there. On the other end, I also told you about gamma particles that they are just energy waves, no change in atomic number and atomic mass over there. You can be taken over there in the form of different examples by keeping it in the mind over there. This was related to your basic radioactivity of lecture 1 over there. But the next one, in the next video, we will talk about half-life and uses of nuclear radiations and with their advantages and disadvantages over there, and nuclear fission and nuclear fusion will also be discussed in the coming videos. Kindly subscribe my channel and stay blessed and stay concentrated or connected with the books for your great success. Thank you so much for today. Allah Hafiz.